track, of the blockchain track. And so I'm the host of this track, but I'm also the last speaker. And today I'm going to talk about some interesting application about identity. Okay, so as I know, there were not so many people talk about identity, especially self-sovereign identity. So what this means is an identity that's totally controlled and owned by the user, the customer itself. So this is outline, and this is a link to this slide. So you can just scan this QR code, and you can download the slides, and you will make this bit easier. Since I'm talking English, okay. So today I'm going to talk about 5 parts. First of all, I'm going to introduce the digital identity, the definition of it, and what are the components and elements. I'm sorry about the size of the font. It's kind of small. And the second, I'm going to talk about the architecture. And this third part is organizations, like what organizations are behind the SSI pushment. And the most important thing is what are the specifications of implement these identity, how can we make that happen? And the summary. Okay, so let's talk about the digital identity. So first of all, today's talk is actually, the resource is actually from my previous article. So if you download the slides, you can actually link to this article. It's in Chinese. Yeah, it's easier to read. So we all have experienced that being asked, who are you? So think about it. How did you answer to this question last time when someone asked you? Did you answer your job title, or did you answer your ID card number, or did you answer maybe some event ID? For example, the COSCUP, when the COSCUP attendee, when you try to enter the COSCUP venue, so someone asks you, hey, what's your ID, right? So the identity itself it actually depends on the scenario. So it depends on where you are and what the people you're talking to, who are you interact with. So digital identity is kind of sort of things. It's the identity that expressed and stored in digital form. Okay, and it actually depends on the scenario, situation you are in. So there's a really famous article talk about the evolution of the digital identity, and it was written from 3 years ago, and it has 4 phases. So the first phase is called centralized identity. That means, well, the identity is actually stored in the giant database. Okay. So why should we need a digital identity for this? It's all because the triple W, right? World Wide Web. Since the World Wide Web is coming up, so we always have we started to use email, we started surf internet for buying stuff, sort of things. So digital identity has a large demand with the popularity of the World Wide Web, and we actually had Dominic talk about this certificate authority, and it's actually the first attempt that people tries to make the website trustworthy. Right? We have to trust the website we are serving, we're using. So CA is established to be responsible for the issuance and of the certificate. Okay, so you can see the diagram here. So we have a CA probably, and we have different levels of CA. So the root CA, we probably have like 50 plus root CAs, and we have intermediate CAs. So it's like a hierarchical structure. Okay. So the CA will issue the certificate to the website domain owners, and then we are the people who try to access the internet, right? Access the service. So the reason we can trust the website is because they have a small lock sign on the URL address. Right? So the only problem with CA is it's really centralized and it's hierarchical. So what if the root CA is not trustworthy? That means, well, if it's not trustworthy on the top, and we cannot trust every second level CAs behind that, right? So, and when we try to use the internet services, that means we have to trust each single website, right? For example, I'm using Facebook.com, right? So I have a Facebook account, but I'm also using GitHub. I'm also using YouTube. So as long as I'm using more services, my identity is actually broken and very fragile because it's spreading here and there. It's pretty hard to use. It's pretty hard for me to manage. So identity is controlled by the domain name owner. That means, well, if Facebook tries to shut down my account, there's nothing I can do about it. Right? A user may have to register for dozens of services for the same time. So people start to think about, hey, what can we do about this? An easier solution is to make an alliance. Right? So what if, for example, I'm registered a service at this domain, and this domain is actually forming a federation. It's a federation. So I'm using service from server A. That means, meanwhile, I can get access to different servers. Okay, this is called Federated Identity. That means these services are forming a group which allows me to access every single service. So let identity be managed by the coalition of several organizations. So the first federation is called Liberty Alliance. It's in 2001. It's led by Sun, the microsystem company, which invented Java. But however, identity outside alliance, as you can see, these two services they didn't join the group. They didn't join the alliance. So if I try to connect to the service here, I still have to register, right? So it doesn't really solve the problem. So now let's move to the next phase. So this is where I am now. We are currently in the user-centric identity phase right now. So, for example, if we try to get some tickets from KKTix for COSCUP, for example, do we have to register a KKTix account? We don't, right? We can actually sign in via Facebook. Okay. The reason we can do that is because there's a protocol, there's a specification underlying the registry process. So each service needs to work together to develop the same set of spec to verify identity across services. Okay. For example, like I can sign in using Facebook. Probably so developers are here, right? Probably you heard about OAuth or FIDO or OpenID, this sort of things. Probably you have been using some of the APIs from those. So there are two main things are focused here. The first thing is called user consent. That means whenever the service is trying to access my data, they have to ask for my permission. For example, well, it's not really a good example, but when Facebook tries to access your email account, they will ask you, but we always click yes. But anyway, that's another story. They're selling your data. And the other thing is called interoperability. That means you can use the same account among these different types of services. So this is what we call user-centric. User-centric equals consent and interoperability. So here are some examples. You can OpenID, OAuth, and FIDO. So, but does this solve the problem? Not really, right? Because users are still dependent on centralized services. Right? Our ID is still kept by Facebook, kept by GitHub, YouTube, Google Drive, whatever. So these services actually have the power to abuse our privacy. For example, Google sells advertisements, right? So when some other marketers, marketing company, they can actually use GA, right? That means Google are selling our data to them, for them to target in our interests, target our what are the things that we feel interested about. Right? And they're actually causing some GDPR issue here. So here's the question, the real question. So how to implement? How can we, as in a blockchain era, how can we implement an identity that is not controlled by the centralized services? So the answer, obviously everyone knows it, is distributed ledger, blockchain. So blockchain is the last piece of the puzzle. So let's take a look, how can we use that? So the identity that is implemented on distributed ledger is called self-sovereign identity. So in short, SSI. So SSI is a digital identity that users can fully control and use between any services. The term fully control means only the one who holds the private key can access the identity. Right? So it's all about cryptography, the private key. So SSI is anchored to distributed ledger. So this actually gives us 5 really good properties. So the first thing is existence. That means identity is anchored in a form of digital identifier. It's actually a string of alphabets in random orders, and it can help us if we put this string on blockchain. It can help the string protected from tampering. No one can modify the value of the string. Okay, and the second thing is control. So the blockchain can use digital signature and private key, and who owns the private key, only the one can use use identity. And so if you protect the private key very well, so no one can actually get it. So you are the only one who hold the identity. No one can use it. The third thing is access. Okay, that means because the blockchain is decentralized services, distributed systems. It's a replicated state machine. So there are many replicas around the world. So it's really hard to block every peer at the same time in the world at the same time. So the access can 100% be guaranteed. Okay? And transparency, every data and every single bit is going to be recorded on blockchain transparently, obviously. And persistence. Okay, so persistent means so when you're using some centralized server, well, it's very likely that it will be shut down, right? It will be disrupted due to some DDoS attack or whatever. But on blockchain, because these miners are actually incentivized to provide a service and bandwidth, so it's very unlikely for these miners to suddenly just going offline or shut down services. So persistent, protected. Okay. Okay, so now let's talk about the architecture. So there are actually only four components here. So DID layer. So you can think about it as the bottommost layer, which anchors our DID stream. Okay. And on top of it, we have a management system. You can think of it as it's an app that allows us to access our property. It's like a digital wallet. It's like a wallet you're using when you try to transact in Bitcoin or Ethereum. And this third part is we call it authentication. Authentication means whenever we want to try to use a private key to assign some value, then the receiver has to authenticate to verify, are you really the owner? Okay, basically. And the fourth thing is we call it quick credentials. So let's take a look one by one. Oh, by the way, this architecture, it's actually arranged in stack. That means the upper layer actually relies the bottom layer. It's like a TCP/IP suite. So application layer relies on the TCP layer and relies on the IP layer. The work relies on IP layer, the physical layer. So it's a stacking architecture. So here are some organizations that try to push SSI forward. So, for example, rebooting Web of Trust, it's actually a workshop. I believe they're hosting every 6 months and try to generate some really good results on the identity draft. And there's a W3C, Financial Committee Group, which helps to draft, to make this draft into a standardization. And there's the DIF Foundation to work, tries to bring in every cooperation together to deliver on the specifications. And there's a conference called IIW, Internet Identity Workshop. So among these 4 organizations, the most significant one is RWT, Rebuilding Workshops. Why? Because they publish so many papers. They publish a lot of open source code, and they're actually helping to transform the technical specifications into standardized. Try to help standardize these specs. And even the term SSI, self-sovereign identity, is invented by RWT. So it's really significant, really important. So the DID specification draft is largely based on the RWT's work. Okay. So, 5 minutes left. So now let's take a look at stack one by one. So the first stack is called DID. So it's really simple. It's just a string that get anchored on blockchain and look like this. Okay, so there are actually 3 parts. This part is part of this part. So DID, so this is actually a universal unique ID in the form of UUID. And the first part is so it should be used under DID specification. And the second part is how should a node resolve the string? So for example, now we're using the Sovereign blockchain or Ethereum blockchain. If I'm using Ethereum blockchain, it should be ETH. It just specify what resolution I should use. And this is a unique string. You can think of it as a hash, something that you can identify the identity. Okay. So this is a bottommost layer. So on top of it, we have a second layer, right? We have a DKMS layer. It is called Decentralized Key Management System. So you can imagine the task of this layer is to manage the private keys, right? And beyond that, it has to store the user data. Okay. For example, probably some credentials, probably some personal encrypted data, probably the photos, the text, you name it. Okay, so we can actually divide this into 3 different layers. Okay, so DID layer is something that talks to the bottom layer, the bottom DID layer. So it just basically requests the bottom layer to look up DID. So hey, I have a DID string, so could you please help me to retrieve the document? Okay, and then this is cloud layer. Cloud layer is somewhere we store the data on the cloud. For example, like Google Cloud, AWS, Microsoft Azure. So edge layer is an app you're using. It's a wallet you're using. Okay. So the user actually mostly interact with the wallet, and then use the underlying services. So now things are getting interesting. This is the third layer, authentication. Authentication, as I said, it means whenever I try to log in the services, the service provider has to authenticate me. Am I really the user they're talking to? So the easiest way to think about it is whenever we try to log in the website, we have to type in a password, right? So the password is actually a challenge response cycle. That is a challenge set by the provider for us to prove we are the user, because ideally only the user knows the password, right? If your password isn't hacked. So we can think of it as a authentication processes, but of course, in this scenario, in the DID scenario, it will become sort of more complicated because we cannot just expose our private key or password. Okay. So there's research going on. And I actually put the spec link on every slide, so if you're interested, you can check. Okay, so the first part, verify the credential. So what is a credential? Credential is probably your student ID card, your ID card, your driver's licenses, your membership card from a bookstore, whatever. So it's actually some document to prove you have a membership or you have to prove you're part of the community. Okay, this kind of things. So So when you graduated, probably the school will issue you a credential as well, for example, from NTU. So the only purposes of the verifiable credential is to replace every ID card in your wallet. Okay. So in the future, we imagine, well, when I take out my digital wallet, I can have every kind of credential stored in my wallet, right? For example, my student card, I can just show on my digital wallet and say, hey, this is my student card. So what is verifiable means? Well, it just means it's cryptographic digital certificate protected by cryptography, magic, the block magic. There are actually 3 parts. So we have claims. Claims is it's a relation. For example, Alice is a student from one school. So this is a relation. This is a claim to prove the relation. Okay. And some metadata, for example, the issue time or release dates, some other not so important information, and a proof. Proof is basically digital signature. Okay. So so there's a more advanced spec, which is called a verifiable presentation. This actually uses ZK-SNARK, okay, use zero-knowledge proof to protect the privacy of the credentials. So it's pretty complicated. I didn't really get it fully. Yeah. So anyway, it's a more advanced topic to talk about. Okay, my time's up. All right, this is a summary. Yeah, I get it. So this talk is expected to help researchers and developers to quickly get a sense to understand what is going on in SSI and what is identity, digital identity. And the development of SSI is really short, only 3-4 years. But as you can see, there are many significant results coming out, and there are many new applications, protocols, specs continue to develop. Actually, as I know, there are some team based in Taipei actually working on this direction. Okay. And since it's a fairly normal field, information is open, scattered everywhere, and it's really hard for, I know as a developer researcher, it's really hard to get information right. So I hope this talk will help developers to save the time. Okay. So this is my talk. Thank you. And I'm actually a writer. So here's my media, JUINC, my Twitter. So just don't hesitate to follow me. Thank you. Yeah. Any questions? You can ask in Chinese. Yeah. 老师。
谢谢。就说请教像这个SSI 它跟您刚刚的 Unitychain 是一起的，是不是？
是，就是我刚刚没有讲到我们公司在干嘛的。I want to answer this part in English. So Unitychain. Let's go back first. So right now I'm a Unitychain researcher. What we're doing is we try to implement the specs of the DID, of SSI specs, and we try to make a platform, a dashboard for customers to manage their identity. For example, they can access to different kinds of social medias only from our dashboard. So development is really quick and still underdeveloped. And we're sure as long as we get some interesting result, we'll let you know. Okay. Yes, we're actually doing something related to the DID. Yeah, that's true.
Sorry.
Yeah.
Could I in Chinese? Sorry. Sorry. 因为我也是思考啊，像从 Internet 起来的过程，就是说，比如说现在大家都用 Facebook ID 啊、Google ID 这些，就有 application， 它再来 ID 起来。那这个的 idea 就是说，在 Decentralized 世界，因为我看到你是倒着走啊，就是说，你推了 SSI， 大家就要用这个要怎么跟从互联网起来的过程哦，这个要怎么完成？因为以前的话都是application 起来了，然后比如说 Google dominant、Facebook 在 dominant 这些，那大家自然每个人都有 ID， 那就是说很多就愿意用他们的 ID 嘛。那现在您是提了一个 SSI 或者 刚刚听到最主要是不是 rebooting Web of Trust 那个题的？
对，
这个是好。那这个他们有什么这种切入点，说大家就要用他们的
Okay. So the professors ask about what's the reason for us to switch from the current identity architecture to SSI. I think that one of the really strong motivation is the GDPR issue. Okay, so GDPR issue means the user's data is actually not well protected. So our data is abused by the giant companies that are selling our data to the various kinds of marketing companies. For example, there's a scandal. It's called Cambridge Analytica. Right. If you know, the team actually helped the Trump campaign, Trump president to win a campaign, and they actually abused the Facebook data, right? So I think GDPR is a great power to remind people about the importance of privacy. So we can see the projects about the Mimblewimble and some cryptocurrencies that are focusing on privacy. How do you hide information from being exploding on a blockchain or on the internet? So if we have this SSI architecture, that means our data is kept and owned by our own. So let's go back to the architecture here. So in this architecture, you can see there are only two important parts. This part is the blockchain part. This is blockchain, and our ID is anchored on blockchain. So what is this? Well, it's actually have a lot of things. It has 3 layers. So especially here in cloud layer. So you will ask, well, if the user has to keep the data, where should we store it? We should store it on the cloud. But remember, the data is encrypted by the private key of the user. So even if we store the data on Google Cloud or Amazon, they cannot just access it or read it because it's all encrypted, right? So of course it will make things more complicated. For example, what if I try to sell my data? I am the user. I try to sell my data back to Facebook or back to YouTube maybe. So how should I work? Well, it's another open question for us to explore. Yeah. So yeah.
I'm just helping because helping you give motivation for me also. Myself also, because back to the slide just show the blockchain. My thing is like for Bitcoin blockchain, then because it's anonymous or pseudo anonymous, then we don't have this like实名制ID problems. But if we talk about like a fintech blockchain, then we run into this identity problem. Then I believe blockchain is not the second internet because internet is application basis, O2O, online to offline. But once you touch the fintech blockchain, it's off to on. It's not on to off. It's offline to online because you need to deal with the real ID. So I was thinking if we, because I have been like pushing for the blockchain adoption for the past few years. I found it's really not the internet adoption story again. It's not the second internet. Thanks for your talk because then this way help us. But like now, I believe the world has come on internet, but the world hasn't adopted ID yet. The digital ID is not happening as we speak yet. And then this the way digital ID come along. I believe based on my failure in the past few years, I believe we need something like SSI, and then we need to rethink. And it's not like the app 它是食衣住行嘛，所以它就每个人都可以用。但是到这个你到 fintech 的时候，它是数字 ID 的时候，它就不是 O2O 了，它真的是 off to on， 它是另外一个 O2O。
You're right. Yeah, very interesting point of view. Yeah.
好，那还有问题的话，
有问题吗？可以私下
再找邱俊。然后今天的 track 就到这里。
OK，
谢谢大家参与，谢谢。